In this lecture video, we begin looking at how statistics deals with uncertainty and chance in making decisions. In particular, we'll be looking at probability as a way of quantifying uncertainty and chance. We'll start by identifying the cause of uncertainty in real-world decision-making. We'll specify the general way in which statistics deals with that uncertainty. We'll identify different ways of quantifying uncertainty and chance. In this video, our focus will be on probability as a way of quantifying uncertainty and chance. In our discussion on probability, we'll identify the three types of probability. So let's begin our discussion of probability. A very important reality to be faced in real-world problem solving is that we almost never have all relevant information about the problem at hand and its context. The information we do have is incomplete. This lack of complete information creates uncertainty. Effective problem solving requires that uncertainty be taken into consideration when making data-based decisions. One of the strengths of statistical methodologies is that they formally incorporate uncertainty into the decision-making process. They do this by intentionally injecting randomness into an experimental situation, either through the sampling process in population sampling studies or through randomized treatment allocation in designed experiments. This injected randomness, this randomness injected with a purpose, creates a probabilistic structure that can then be accounted for in the decision-making process and in particular in the statistical analyses. The particular sampling design, in the case of a population sampling study, or the experimental design, in the case of a designed experiment, determines the statistical model and the appropriate method of analysis to be used in analyzing the resulting data. It's therefore extremely important to determine exactly how an experiment has been conducted in order to identify the appropriate way of analyzing the data. Using statistical models and/or methods of analysis that are inconsistent with the manner in which the data were generated do not produce valid results that can be relied upon. And so it's very important to identify the way in which the experiment was conducted so that we can identify the proper statistical model and the appropriate methods of analysis. So now let's look at how we can quantify uncertainty and chance. Uncertainty and chance can be quantified in a variety of related ways: probability, odds, logits, and entropy. Statistics incorporates uncertainty into the decision-making process through the use of probabilistic models. Our focus in this lecture is on using probability to quantify uncertainty and chance, which can then be incorporated into the modeling process and in particular into the statistical models. Let's take our first look at probability. In thinking about the concept of probability, there are several things to consider. What is probability? And what is a probability? How is a probability obtained? How is a probability to be interpreted? And what properties do probabilities possess? Now, what is a probability? There are three ways of approaching the notion or the idea of probability: the classical approach, the relative frequency approach, and the subjective approach. Sometimes we say that there are three types of probability: the classical type, the relative frequency type of probability, and the subjective type of probability. The approach used in defining probability also determines how probabilities are to be interpreted. So let's look at the classical approach first. Under the classical approach, the probability of an event is defined as the ratio of the number of cases favorable to that event to the total number of cases. So it's a simple ratio. Now, the classical approach is applicable only when outcomes are equally likely. Properties for classical probabilities can be mathematically derived. Here are a few questions to consider when thinking about classical probability. What is the appropriate way to interpret such a probability? What is its connection to reality? And a related question, what does it mean from an operational standpoint? From the standpoint of practice, what does a classical probability mean? Next, let's look at the relative frequency approach, or relative frequency probabilities. Under the relative frequency approach, the probability of an event is defined as the limiting value of the relative frequency of the occurrence of the event in an infinite sequence of trials. Now, some questions to consider when thinking about relative frequency probabilities. Can an infinite sequence of trials actually be performed in practice? In a given situation, how do we know whether relative frequencies actually converge to limiting values? Can relative frequency probabilities be exactly determined mathematically? And if not, how can relative frequency probabilities be determined at all? In order for the relative frequency approach to probability to be applicable and meaningful, we must be able to frame the event of interest within an infinite sequence of identical trials or as part of a mass phenomena. When this can be done, clear-cut interpretations and connections to reality exist. And finally, properties for relative frequency probabilities can be mathematically derived. Finally, let's look at the subjective approach to probability. Under the subjective approach, the probability of an event is a personal subjective assessment. Because it is a personal subjective assessment, at a given point in time, the subjective probability of a given event can, and probably will, vary from one person to the next, as well as from one time point to another for the same person. Finally, there is no prescribed way of determining subjective probabilities because they are indeed personal and subjective. Different people looking at the same event bring with them different pieces of information and valuing things in different ways. And so there's no single way to come up with these subjective assessments. A few questions to consider about the subjective approach to probability. What properties do subjective probabilities possess, if any? How can these properties be determined? And can these properties be derived mathematically? So let's summarize what we've covered. Uncertainty in the context of problem solving is caused by a lack of complete information about the situation at hand. Effective problem solving requires incorporating that uncertainty somehow in the decision-making process, and we know that statistical methodologies formally do that. Probability is one of several related ways of quantifying uncertainty and chance. There are three types of probability: classical probability, relative frequency probability, and subjective probability. So that's all for now. In the next lecture video, we'll cover the other ways of quantifying uncertainty and chance, in particular odds, logits, and entropy. I'll see you then.